Okay. This is only for the super interested students that are interested for a partial incomplete exploration. When I ask the question is, I want a physical representation of the dot product. I'm not even going to say this video is gonna serve that purpose perfectly, but let's explore a little bit. So I'm using this as a base to talk about it. Just an example that has no real context. It just says find the work done. It says down, moving up. It's supposed to be the work done, moving an object from the point 1, 5 to 9, 14 by the force vector 3, 2. So this is actually a fairly simple problem to solve if all you want is the answer. All you have to really realize is the vector in traveling from 1, 5 to 9, 14. The x unit is going from 1 to 9. I'm looking at this right here, by the way. The x unit is going from 1 to 9. That's a distance of 8. The y unit is going from 5 to 14. That's 9. It actually doesn't matter positionally where it is. What matters is it's going horizontal 8, vertical 9. So think of that as the vector 8, 9. And to solve this is pretty simple. It's quite simple. That vector 8, 9 times the force vector 3, 2 will equal the work. So 8 times 3, this works out to be 8 times 3 plus 9 times 2, that's 24 plus 18, which is where we get that 42. Okay, so that's the answer, right? Maybe you got that, great, but maybe you're just like, right, that's 42, I guess that's the answer. So here's my attempt to try to understand this. And again, I won't even say that I'm there at this point. But the first thing that I wanted to do was so you see in the drawing, I've got the vector 8, 9, and the vector 3, 2 to really represent F and that movement that it's going. I can almost picture pulling a trunk, like for whatever reason, I have to pull it a little bit of a down angle in order to pull a trunk up a slope or something like that. And this is the amount of force I can put on it. So first thing I'm going to do is just find out what angles and magnitudes I'm working with. So as far as angles go, I want to know what this angle is, and I want to know what this magnitude is. So that's pretty simple. This is 3, this is 2. So this is going to be the square root of 3, the square root of 13. And I would give that's about, it's between 3 and 4. I'm just going to call that about 3.6. So really talking about this 3, 2. That would be the magnitude of that vector is about 3.6. And the angle here I could solve with, now that I have all 3 sides, I could use any number, but I started with 2, 3. So I'm going to do the arctan of 2/3 and make sure I'm in radian mode, and I am. So I'm just going to arctan of 2/3. This angle right here ends up being about, well, no, actually I lied. I'm going to do it in degrees because I did this in advance in degrees just because it helped me. In degree mode, the arctan of 2/3 that's about a 33.7 degree angle. I'm just going to write that in as 33.7 degrees. Okay. I'm going to pause with that. And I'm going to go over to my purple here. And I'm going to look at this angle. And I'm going to look at this magnitude very similarly. But I can work with similar things and saying that we know that this is 9. We know that this is 8. So it turns out that 8 squared is 64, 9 squared is 81. If you add 64 and 81, you get 145. So that's going to be 145 right there. So the magnitude, let's just call this A. And the magnitude of A is going to be the square root of 45 is 145. And I'm just going to actually do that. Square root of 145 is about equal to, it's about equal to 12.0. So I'm just going to say it's about equal to 12, which makes sense. Square root of 144 is 12. So that's just a tiny bit more than 12. All right. And the angle there, I'm going to use arctan again, and just 9 divided by 8. And it turns out that this angle is about 48.4 degrees. So I just want to point out that the difference between these angles, let me bring in a new color here, bring in red. The difference between these two angles, which is this angle right there, is going to be 48.4 minus 33.7, which is going to be about a 14.7 degree angle. And I'm going to tell you why I'm going to do that is because I'm basically going to rotate this whole thing. And so I'm looking at it flat to the axis just to make a little more sense of it. So I'm just going to also say that if we call this purple alpha, I'm just going to say alpha minus beta equals 14.7 degrees. And that the difference between the two angles. And then hopefully this doesn't drive you all crazy. I think I wrote everything down, 3.6. I guess I didn't write down the magnitude of A. I'm going to erase everything. Erase all that work. This is a video, so if you're like, don't erase it, remember you can hit rewind. And basically, I'm going to also erase, select, there you are. Erase these. Oh, it's not letting me. Why aren't you doing that? Select objects. Just keeps using an eraser. I don't know why it's doing that. Let's see. Straight connector. That one, yep, delete it. Straight connector. That one, delete it. Okay. And now I'm just going to switch and I'm just going to go, okay. So instead of that, I'm going to think we've got our force vector is about 3.6. So I'm just going to draw right there in green that little leg just to kind of represent the magnitude of 3.6. I'm going to write it right there. And then I am going to, at an angle of 14.7, which I don't know, maybe looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's probably going to look something like this. I could figure out the exact length. In fact, I did that at 11.6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like about like that. Actually, I'm going to erase that because I figured this out in advance. I figured out that if I had this 14.7 degree angle, that would actually be at 11.6, 4, 5, 6, 7, 8, 9, 10, 11.6, and then up about 3. 1, 2, 3. So that would put me about there. Let me switch. So this isn't going to be perfect, but gives you an idea of here is that movement, that same distance of 12. It was exactly the square root of 145, but we'll estimate 12. Brings us about right there. So the question is remember the work on this is 42 degrees. Or not degrees, it's just the amount of work is 42. So if I kind of drop this down and said, okay, the horizontal force here, that X variable is about 11.6, so I'll call it 6.5 is what it rounds to. And this is kind of where we're at, really watch this, that if we look at this and I look at this as, I'm going to go 3.6. I'm going to rotate that 1, 2, 3. I'm just going to rotate that so it creates a vertical line instead. And then I look at this 11.65 distance and drop it to that same 3.6. Just going to double check this. 3.6 times 11.65, and these are rounded numbers, equals 41.94. So unrounded, the area of this would be 42 if you didn't round this. So again, maybe this like makes sense to you. Maybe you'll talk to me about afterwards and say, oh, that makes so much sense. But But again, this is kind of an open exploration where I was asked by you all and asked by myself. I had wanted this before you ever asked this. What is 42 what? Like, what is that thing? So, and just kind of talking through this with a colleague and looking at this and kind of looking at the numbers involved, taking some of the complication of the twisted angle of it, just say, if we're looking at the sort of horizontal force of this compared to the force that you're exerting on it, that does create this area of 42 on this rectangle. Again, this is a little incomplete, but I just wanted to come up with a physical representation of that work done. And this process got me there. So take it for what it is. Hopefully you got something out of it.